Helical Springs, problem 1, that is example 3.1. Design a helical compression spring to support axial load of 3000 Newton. Deflection under the load is 60 mm. The spring index is 6. The spring is made up of chrome iridium steel and a factor of safety of 2. So here the given things are axial load F is 3000 newtons, Y is 60, spring index means C is 6, Fy is 2. So now they have said the material is chrome vanadium. So from table 20.12 we can use shear stress yield 0.699 GPa, 690 MPa, and G is 79 GPa. So this we get from the written book. Now allowable shear stress tau is tau y upon Fs, that is 690 upon 2, that's 345 Newton per mm square. So the table 20.12, so for chrome vanadium, so the tau y shear stress yield 0.69 or GPa or 690 MPa, and the modulus rigidity is 79 GPa. Now the procedure. So first is to find the diaph spring. So we have to use the equation shear stress tau equals to 8F dk upon pi d cube, that is 20.22. So first find the K value. So force K value is 4C minus 1, 4C minus 4 plus 0.615 upon C. So this is 20.23. So we'll substitute the value of C. So we'll get 1.2525. Also the spring index, C is d by d, or C is equals to C d by d, or d equals to 6 into d. Substitute. So in this formula, substitute the tau 345 8. F is the axial load 3000. D, capital D is 6 times small d, 6 times small d. K is just now 1.2525 pi d cube. So D is an unknown value, that is 12.89. So 12.89 from the diaph wire, so the nearest value is 12.13. you can take it as 13. Now D is 13. So now next second procedure, diameter of coil, C is d by d. So mean diameter d, capital D is 6 times of small d, 6 times of small d. So therefore it will be 78 mm. Similarly, DO is d plus d, that is 78 plus 13, that is 91. DI is d minus, that is 78 plus 13, that is 65. Next procedure, the third step is number of coils or turns of the spring. So deflection. So in the equation is y equals to f d cube I of d raised to 4g, that is 20.29. So in this y is given, that is 60, f is 3000, capital D is known 78, I is unknown, small d is 13, g is 79, 10 raised to 3. Substituting this, we get it as I equals to 12. Now field length is LO. This formula is not in the written book. So remember, LO is greater or equal to 1 I plus N D into plus Y plus A. So A is 25% of maximum deflections, 25% of 60, and N is 2 assuming square and ground ends, and I. So therefore I is 12 plus 2 as N is 2, then D is 13, Y is 60 plus A is 15, so we get it as 257. Now the pitch. Next procedure, the pitch, to find the pitch. So to find the pitch, formula is L upon S2 divided upon I. So we get it as 19.28. Last, the required stiffness, that is Fo equals F power y. So load by deflection, that is 50 Newton per mm. Actual stiffness Fo is d raised to 4 g I d cube. So 13, small d is 13, g is 79, 10 raised to 3, 8 is 8, I is 12, capital D is 78 cube. So we get 49.74. So these are the specifications of the Helical Springs.